Hello students. So today we will solve some questions on the surface chemistry that has been come in the CSIR NAT exams. And our first question is from the December 2016 exam. The question is when 1 into 10 to power minus 5 grams of fatty acid that has a molecular weight 602.3 grams per mole was placed on the water as a surface film, a monomolecular layer of the area 100 centimeter square was formed on compression. And we have to find out the cross-sectional area in angstrom square of the acid molecule. We have given 4 options. Option A is 50, option B is 100, option C is 150 and option D is 200. So if we come to the question again, we can see that we have given the weight of the substance, the molecular weight, and we have find out that there is a monomolecular layer of the substance formed on the water and the area of the layer is 100 centimeter square. And we have to find out the cross-sectional area of one molecule. What it means by? Means the surface area that is covered by the one molecule, and we have given the area that is covered by the n number of molecules that are forming the monomolecular layer. So we have given the total surface area that is forming the monomolecular layer, that is 100 centimeter square. And we have to find out the surface that is covered by the one molecule. So if we want to find out the surface that is covered by one molecule, then we have to find out the number of molecules in a mono layer. That means n sub m. We have to find out this. If we find out this, then we can calculate this one. And we know that the formula for this is n sub m is equal to Na times V sub m divided by 22.4. Here Na is the Avogadro number, that is 6.02 into 10 to power 23, and Vm is the volume of the monolayer. That will be given by Vm is equal to number of the moles, the total number of moles, into 22.4. As we know that the 1 mole occupies 22.4 liters. So we will multiply by the number of molecules. So we can write it like this, number of moles. How we can find out number of moles? For this, we will divide the amount of the substance by its molecular weight. So we will get the number of moles and then we will multiply it by 22.4. So we get our V sub m, that is equal to 1 into 10 to power minus 5 divided by 602.3 times 22.4. Now we will put this value here. So our equation becomes n sub m is equal to 6.02 into 10 to power 23 divided by 22.4 times 1 into 10 to power minus 5 divided by 602.3 times 22.4. If we calculate this value, we will get our answer 10 to power 16. Now this is the number of the molecules that is forming the mono layer, and we have given the total area. So the area that is covered by one molecule can be obtained by dividing the total surface area by the number of molecules. So our equation becomes 100 into 10 to power minus 16 centimeter square. And we can write it like 100 into 10 to power minus 8 centimeter whole square. And we have to find out the answer in the angstrom square. So this 10 to power minus 8 centimeter is equal to angstrom. And the answer becomes 100 angstrom square. This is our right answer. So we can say that our option number B, that is 100, that is this. Option number B is the right answer. Next question is from the June 2016. Very simple question and for the 4 marks. So you can easily cover this question. If you know the full concept of the adsorption, then you can easily go on these type of answers. So the question is absorption isotherm of 3 gases A, B and C are shown in the following figure, where theta is the percentage of the surface coverage. The correct order of extent of adsorption of the 3 gases is, and we have given the 4 different options. So we have to find out the order of the three gases in which the adsorption is taking place to which extent. It means in the order of higher to the lower one. So we have given this type of graph. Here the graph is plotted between the 1 by theta and 1 by p. We know in the adsorption isotherm, as we have seen in our videos, you can see that the adsorption isotherm is basically between the theta and the p. It means theta is what? Theta is the fraction of the surface that is covered by the adsorbate molecules, and p is the pressure. So as the surface area covered by the molecule increases, the fraction of the surface covered by the molecule increases, then the extent of the adsorption increases. So the extent of adsorption increases with increasing the value of theta. But here we have given 1 by theta, the reciprocal of theta. It is not theta, it is the reciprocal of theta. It means if the 1 by theta will increase, the extent of adsorption will decrease. So this gas A that has the highest 1 by theta value will have the lowest extent of adsorption, while this gas that has the lowest value of 1 by theta will have the highest extent of the adsorption. It means for this the extent of adsorption will be highest than for it and than for it. So we can write that this option D, that is C at the highest rate of adsorption, then the B, then A as the lowest one. So option D will be the right answer. Next question is from the December 2014, and in this question we have given three different adsorption isotherm, and our question is the variation of the mass absorbed with the pressure for a monolayer and a multilayer are represented by, and our options are: option A is A and C respectively, option B is A and B respectively, option C is C and A respectively, and option D is B and A respectively. So if we see the question, what we have seen, we have given three different adsorption isotherm, and we have to find out that which isotherm is for the monolayer adsorption and which one is for the multilayer adsorption. There is a graph between the mass adsorbed and the pressure. In the first graph we can see as the pressure increases, the mass adsorbed, it means adsorption increases, and at a particular limit this becomes constant. It means there is no more increase in the rate of adsorption with increasing the pressure. So it will definitely will be for the monolayer adsorption, because in the case of monolayer, when the monolayer has been formed here, then the rate of adsorption will become limiting. It will not increase with increasing the pressure because there is a monolayer formation. So our option A, so our graph A is for the monolayer adsorption. Now we look at the curve B. In this curve we can see this is the pressure and this is the mass adsorbed. As the pressure increases in the initial state, with increasing the pressure the rate of adsorption is increasing, then at a particular limit it becomes constant. Now if we increase the pressure, again the rate of adsorption increases. Why this happens? Because here a monolayer has been formed. Now when we increase the pressure, a multilayer is formed, so the rate of adsorption again increases. So in this case, in the graph B, there is the multilayer adsorption, that is according to the BET theorem. So this curve is for the multilayer adsorption. So we can say our option B, that is A and B respectively, that will be the right answer. The next question is from the June 2014, and the question is for a non-dissociative Langmuir type adsorption of a gas on the solid surface at a particular temperature, the fraction of the surface coverage is 0.6 at the 30 bar pressure. The Langmuir isotherm constant in per bar unit is, and we have given four different options. Option A is 0.05, option B is 0.20, option C is 2.0, and option D is 5.0. So in this question we have to find out the Langmuir isotherm constant, that we denote by K or by K equilibrium. We know that the Langmuir adsorption isotherms equation is theta is equal to Kp divided by 1 plus Kp. Here K is the constant that we have to find out, that is Langmuir isotherm constant, that is K, and P is the pressure. Pressure we have given, that is 30 bar, and we have also given the value of theta. So we can find out very easily this question, and the question is for 4 marks. So only you have to calculate, you have to put the values in this formula and you have to find out the value of K. So for this, firstly we will write it like 1 by theta. We will take the reciprocal of this equation, so that 1 by theta will be equal to 1 upon Kp plus 1. Again we can write 1 upon K is equal to P times 1 by theta minus 1. Now in this equation, this K is a thing that we have to find out, that is the term that we have to find out. So we have given the pressure's value 30 and we have given the value of theta, that is 0.6. We will put these values, so that 1 upon K is equal to 30 times 1 divided by 0.6 minus 1. So we can write 30 times 2 by 3 is equal to 20. It means the value of 1 by K is 20. So that we can take the reciprocal of it. So our value of K, or the K equilibrium, or the Langmuir isotherm constant, that will be equal to 1 by 20, or it can be right that it is equal to 0.05 per bar. So this is the thing that we have to find out, Langmuir isotherm constant. Its value is 0.05. So our option A is the right answer. So you have seen all the questions are very simple. Very simple questions are asked from the surface chemistry, and if your concepts are clear, then you can easily solve all of these questions. So if you want more questions, I will solve more questions from the book. Till then, thank you. Bye bye.